All right, so on page 10 in your notes, first thing we're going to do is define a secant. If I have a line that passes through a circle, I'm going to call this point here A, and this point here B. That line, so in this case line AB, is called a secant. Now, if we're just looking at the part of that line that stops at the edge of the circle, that's a chord. So a secant passes all the way through a circle, and a chord stops at the edge of the circle. We are going to learn some formulas for interior and exterior angle measures that are not central angles, not inscribed angles. So looking here where it says interior angle, let's go ahead and number these angles. I'm going to call this angle 1, angle 2, angle 3, and angle 4. Angle 1 is intercepting this arc right here. And angle 3 is intercepting this arc right here. But angles 1 and 3 are vertical angles, so angle 1 and angle 3 are congruent. If I want to find the measurement of angle 1 and or angle 3, we're going to use these arcs that are being intercepted. So we have, let's say, the measure of angle 1 is equal to 1/2 times the measure of arc AD plus the measure of arc CB. So the two arcs that are being intercepted by angles 1 and 3, those vertical angles, we take those arc measurements, we add them together, and then we cut them in half to get angle 1. If I wanted, say, the measurement of angle 2, that would be 1/2 times the measurement of arc AC plus the measurement of arc DB. And I always remember this formula that we are going to add the two arcs together, because when I have chords or secants crossing inside my circle, it kind of reminds me of a plus sign. And so I remember that we're going to be adding those angles together. All right. Exterior angles. Let's come over here and look at this picture here. For exterior angles, I'm still going to be looking at the arcs that are being intercepted. In this case, these two arcs are being intercepted by angle M. So if I wanted the measurement of angle M, I would do 1/2 times arc OQ minus arc NP. I forgot my measurement on there. Sorry, let me fix that. Measurement of OQ plus measurement of NP. So we're going to take the bigger or the farther arc minus the smaller or the closer arc. So when the angle that I'm looking for is formed by two secants that are meeting outside my circle, I look at the two arcs that are being intercepted by that angle, and I take the farther one, the bigger one, minus the closer one, the smaller one, and then I take that difference and I cut it in half, and that gives me my angle measurement. Give everybody a chance to catch up, and then we are going to summarize all of the different ways we have of measuring angles, and then we'll do a couple example problems. All right. So let's talk about our angle rules real quick. Central angles. Wrong shape. A central angle is an angle that has its vertex on the center of the circle. And the measurement of the angle is equal to the measurement of the arc. An inscribed angle is where the vertex of my angle is on the circle. So something like this. And then the measurement of the angle is equal to 1/2 the measurement of the arc. And those are the two that we'd studied already. Today we added inside and outside angles. For my inside angles, we have two chords or two secants crossing inside the circle. The measurement of the angle is equal to 1/2 times arc plus arc. And for outside angles, so something that looks like this, the measurement of the angle is equal to 1/2 arc minus arc. So much of this depends on where the vertex of the angle is. Is the vertex of the angle at the center of the circle, on the circle, inside the circle but not at the center, or outside the circle? Right. Give you guys a couple of minutes to finish with these sketches and the formulas. Now for the inside angle and the outside angle, I will give you those formulas. You do not have to memorize the inside and outside angle formulas. You do have to memorize the central angle formula and the inscribed angle formula. So you do have to know those two. All right, let's look down here at number 3, part A. We're going to find the measurement of angle MKP and the value of x. So angle MKP, well, here's M, here's K, and here's P. So this is the angle that we're looking for. Is that vertex at the center of the circle, on the crust of the circle, inside the circle, or outside the circle? The vertex of the angle is outside the circle? Where's the vertex? Which one of these pictures does this look like? Central angle, inscribed angle, inside or outside? So it has it's an inside angle. It does not have its vertex at the exact center of the circle. If you don't see the vertex on the exact center of the circle, it cannot be a central angle. So this is an inside angle. So the measure of the angle is equal to 1/2 times arc plus arc. So we want the measure of angle MKP. That would be equal to 1/2 times the arcs that are being intercepted by this angle and its vertical angle. So one of those angles is this one right here, 55 degrees. And the other is this one right over here, kind of like a vertical angle. This would be the vertical angle to this. And so this is the arc that's intercepted by the vertical angle. So we do 1/2 times 55 degrees plus 75 degrees. What do we get if we add 55 and 75 together? What is 55 plus 75? 130. Yes. And so I want half of 130. That's going to be the measurement of angle MKP. What is half of 130? 65 degrees. They also wanted me to find the value of x. X forms a linear pair with angle MKP. And what do we know about linear pair angles? They make a straight line. They add to 180. They add to 180. So x degrees plus 65 degrees equals 180 degrees because they're a linear pair. So then we subtract 65 from both sides. Thank you. What is 180 minus 165? Yep. 115, absolutely correct. So x is 115. 65. That's why 65 is the thing that's written up on the board. All right, let's come over here and try part B. Are we looking at a situation on part B where it's a central angle, an inscribed angle, inside or outside angles? Inside angles again. We have two chords that are crossing inside the circle, but not at the center. So these are inside angles. If we're going to find the measurements of inside angles, then we need two arcs that are opposite each other. Like this arc right here, and this arc right here. Is it X or Y that's intercepting one of those arcs? X is intercepting one of those arcs. So the measurement of the angle is equal to 1/2 times arc plus arc. The first angle that we're looking for is X. So X equals 1/2 times 129 degrees plus 71 degrees. What do we get when we add 129 and 71 together? 200. And then what is half of 200? 100. So X is 100 degrees. And then what would I need to do to find Y? Not plus 129. Plus 100. Yes, it's plus the angle, not plus the arc. So Y plus 100 degrees equals 180 because X and Y are a linear pair. So then we subtract 100 from both sides. And that means Y is how big? Y is 80, yes. Lovely. Lovely, lovely. All right, let's look down at part C. Part C says to find X. Is X still an angle like it was on the last two problems? No, now X is a what? X is an arc. Are we looking at a central angle situation, an inscribed angle situation, inside or outside? Inside again, yes. All right. So X is this arc here. We have an inside angle situation, so I need the opposite arc, which would be this one right here, 150 degrees. I know the measurement of the angle is equal to 1/2 times arc plus arc. Do we have a size for the angle? Yes, how big is the angle? 110 degrees. This angle is a vertical angle with this angle right here. But what we're looking at, what we put right here is the angle, not the arc. 110 degrees equals 1/2. And now we're going to add those two arcs together. One of those arcs is 150 degrees. And the other arc is X degrees. And now we're going to solve this for X so that we can find the measurement of that arc. First thing I want to do is get rid of this fraction, get rid of this 1/2. What operation will get rid of fractions for me? Multiplication. And what part of the fraction do you multiply by? Denominator. What's in the denominator of this fraction? 2. So we're going to multiply both sides by 2. If you do it to one side, you do it to the other side. So that cancels out my denominator. Technically, that 1 still distributes inside the parentheses. Over on the left, I have 2 times 110. So that would be 220 is equal to 150 times 1 would just be 150, plus x times 1, which is just x. And then we're going to subtract 150 degrees from both sides. What is 220 minus 150? 70. So 70 degrees for x. All right. Let's look at part D. Central angle, inscribed angle, inside angle, or outside angle? Inside again. So let's go look for those arcs that are being intercepted. 53 degrees is one of the arcs that's being intercepted. And arc CB down here, 42x plus 7, is the other arc that's being intercepted. And here's my angle, 114 degrees. The measurement of the angle is equal to 1/2 times arc plus arc. The measurement of that angle is 114 degrees, so I have 114 degrees equals, and then I have 1/2. One of the arcs is 53 degrees, and the other arc is 42x plus 7 degrees. 42x plus 7. We're going to do two things at the same time in this first step. The first thing we're going to do is get rid of the fraction. How do I get rid of this 1/2? Multiply by 2. And if you do it to one side, have to do it to the other side. So we multiply both sides by 2. That's going to cancel out my denominator. I'm also going to combine these two like terms, 53 and 7, together. All right, so let's do that. 2 times 114 would be 228 is equal to, the denominator canceled out, the 1 is still there, and the 1 distributes to every piece here, but that means nothing changes. I do have the like terms of 53 and 7 to put together. What do you get if you add 53 and 7? 60. So I have 60 plus 42x. Then I'm going to subtract 60 from both sides. What is 228 minus 60? 168 is equal to 42x. And then we divide both sides by 42. What is 168 divided by 42? 4. There we go. So far, so good? What questions do you guys have before we flip the page? Good? All right, let's flip the page over then. So now we're looking at part E. It says find the measurement of angle H. Is that a central angle? Is the vertex of the angle at the center of the circle? No. Is this an inscribed angle? Is the vertex on the crust of the circle? Inside angle. So is this an outside angle? Yes. My outside angle is right here, angle H. It is intercepting two arcs. This arc right here and this arc right here. I kind of look at that angle H as being like a flashlight, and those two arcs that are intercepting would be the pieces that are hit by the light of the flashlight. So if I have an outside angle like this, the measurement of the angle is equal to 1/2 times arc minus arc. So my angle is angle H. Measurement of angle H equals 1/2. I'm going to subtract my arcs, and I want the bigger one first. Which arc is the bigger arc? 88. So 88 degrees minus, and now I want the smaller arc. Which one is the smaller arc? 26. 88 minus 26, and then I want half of that. What is 88 minus 26? 62. So half of 62 degrees. What is half of 62? 31. So angle H is 31 degrees. So far, so good? All right. Part F. Do we have a central angle, an inscribed angle, an inside angle, or an outside angle? Outside angle. And so I need the two arcs that are being intercepted by my outside angle. Here's my outside angle X. Here's one of the arcs that's being intercepted. And here's the other arc that's being intercepted. Do I know how big they both are? No. But what do you notice about that one secant, the secant that's up on top? The secant on top is going right through what? It's going right through the center of the circle. It's going right through that dot in the center of the circle. So that means it is a what? If it goes through the center, it's a diameter. We have a diameter right here. If we stop at the edge of the circle, we have a diameter. What do diameters do to circles? Bisect it, cuts it in half, yes. So if I go from right here all the way around to right over here, that would be how many degrees? 180. Well, it says that the arc from here to here is 100 degrees. And the arc that I have highlighted, the little one, is 20 degrees. So to find that missing arc, I'm going to do 180 minus, and then I'm going to add the 100 and the 20 together. So that would give me 120. So I have 180 minus 120. What is 180 minus 120? 60. So this arc over here is 60 degrees. Now do I have enough that I can use my formula? Yep. We have the measurement of the angle. It's equal to 1/2 arc minus arc. So the angle that we're looking for is x. So I have x equals 1/2 times bigger intercepted arc minus smaller intercepted arc. What is the bigger intercepted arc? 60. Minus the smaller intercepted arc, which is how big? 20. What do we get if I do 60 minus 20? 40. So x is half of 40 degrees. And what is half of 40? 20. So x is 20 degrees. We're going to do G and H. And then we're going to save the last 4 for tomorrow so that I can give you guys some homework time to work on the homework that's due tomorrow so that you can ask questions if you have them. So we'll do 2 more and then we'll stop. We want to find the measurement of angle ABD here. Angle ABD, ABD. We're looking for this angle right here. Is that a central angle? What you looking for? It is the last page. Because we're almost done. Does it have its vertex at the center of the circle? Then it's not a central angle. Is it an inscribed angle? Does it have its vertex on the circle, on the crust of the circle? Where's the vertex? The vertex is outside. The vertex is right here at B. It's an inscribed angle. The vertex is on the circle. This is an inscribed angle. Yep. You thought we were looking at what? We're looking at the angle. We're looking at the angle. So I highlighted the angle that we're looking at. This is an inscribed angle, so the measure of the angle is equal to 1/2 times the intercepted arc. The arc that is being intercepted here is this arc. Do you guys see how that's on the inside of the angle, like the angle is hugging that? If you look at the 2 sides of the angle as arms, they are hugging this part of the circle. That is the arc that's being intercepted. Do we know how big that is? No. But what do we know? I know the other side, and I know all the way around a circle is how many degrees? 360. So we're going to do 360 minus the other side, which is 154. What is 360 minus 154? 206. So this arc over here is 206 degrees. So the measurement of angle ABD is equal to 1/2 of 206 degrees. What is half of 206? 103. So angle ABD is 103 degrees. One more. Central, inscribed, inside or outside? Outside. So for my outside angle, we have the measurement of the angle is equal to 1/2 times arc minus arc. My angle is X times 1/2. And then how big are the arcs that are being intercepted here? 36 and 150. Which one should I write down first? 150. Bigger one first. 150 minus 36. What is 150 minus 36? 114. And so then I need half of 114, which would be 57. So X is 57. All right. That's where we're going to stop for today. That gives you guys right around 10 minutes to look at the homework that's due for tomorrow, and I can answer any questions you guys have about that homework. So please go ahead and pull that out.